This is about Computer Science 2, COP 3503, Chapter 1, Sections 3 and 4, Designing Algorithms, and the Chapter 1 Summary. So there's a method of solving algorithms or creating algorithms called divide and conquer. The first part of it is you start by dividing the problem into subprograms. Many times you should consider solving the subprograms recursively. And in fact, that's what this example in this section is going to do. You then combine the subprograms into a solution for the entire problem. So we're going to start off with something called a merge sort. It divides n elements into two sequences, each with a length of n divided by 2 elements. Now, for this example, if one of those happens to be uneven, it's always going to be the second set which might have the odd element. We then sort the subsequences recursively using a merge sort. Finally, we merge the two sorted subsequences for the final output. So here is the pseudocode for the merge sort. It takes an array named A. It takes an index into the array with the left side or the low side, and an index into the array with the right side or the high side. So we're only going to do this if the length of what's passed in is greater than 1. We set a variable q to be half of the size of all of the data. And then we call merge sort once with the left half of the data, and merge sort again with the right half of the data. Finally, we call a new method function called merge. And merge takes the two sorted arrays and puts them together. So I'm going to break now, and we're going to go ahead and look at a programming example of this. This code snippet can be found on cop3503.ricklineker.com/codeexamples.html. And here you can see we've created a function called merge sort. And this is slightly different than the pseudocode. The pseudocode has two arguments. We only have one because all we need is the size. That's because the C++ language or the C language, same thing, not the same thing, but in this case the same thing, allows you to do this in a more succinct way. The first thing we do is we check to see if the size is 1. If the size of this array is 1, then we know we're done, and we don't have to worry about anymore. We just return. We're not going to do any more recursion. We calculate the size of the left part of the array, and then we calculate the right side of the part of the array. Now notice that the right side might actually have one more element if the size is actually an odd number. And then we recursively call merge sort with the left data, merge sort with the right data. Then we call our merge function that puts them together. Notice here I'm using the same data list that I used for the insertion sort. So let's go ahead and run this guy. Get the same results. You have an unsorted list and a sorted list. Now this is the part that I did not show you, and we're going to go on up here and just take a look at that. And it's actually a fairly simple function. So we have one array, and we know the size of the data on the left side and the size of the data on the right. And we're going to use these indexes here to keep track of where we are on the left and where we are on the right. And that way it's as if we're going to have a left and a right array. In fact, we do have a left and a right array. We just point to different places. So we're going to loop through here until we're done. Here the left side is less, so we put that in there. Here the right side is less, so we put it in the array. And we've allocated this temp array, so that's what we use to populate the original array that was passed in, and we delete that allocated buffer. So this works fairly well and could easily be ported to Java or C# or many other languages too.